In this video, we're going to talk about triangle congruency and take what that idea means and look for some shortcuts. What we call 3 for the price of 6, which means, like, if you look at this example of our congruent triangles that we have in this picture, to say that two triangles are congruent, we need to know that all 6 parts have to be congruent. So the 3 segments, like BC is congruent to FE over here, AC is congruent to FD, BA is congruent to ED, and then also the 3 angles have to be congruent to 3 angles in the triangle. Those are the 6 parts of the triangle. So to truly say that 2 triangles are congruent, we do need to know that all 6 parts have to be congruent, which then allows us to write a congruency statement. For example, triangle ABC is congruent to, which is the equal sign and the little squiggly line above it. So that means congruent to. So triangle ABC is congruent to triangle, and then in a congruency statement we write the vertices that correspond to the vertices in this order. So for example, in this triangle, this right triangle over here, vertex D corresponds to A, so D is going to come first, and since I wrote B, that corresponds to E, and then the last one F. So we get to know that these 2 triangles are congruent because all 6 parts are congruent. But when it comes to proving triangles being congruent, it's really a lot of work to show that all 6 parts are congruent. And the beauty of mathematics is being able to understand the minimum amount of information you need to say the most that you can from it. So what we call 3 for the price of 6 means that we're going to look at combinations of 3 parts, maybe like side, side, side. So if we just knew that in these 2 triangles, the 3 sides were congruent to the 3 sides here, is that enough to guarantee that the triangles are congruent without even thinking about the angles? Okay, or maybe we have a side, an angle, and another side. Okay, so is that enough to guarantee that we have congruent triangles? So in this quest, in this investigation, you're going to open up your 3D game. Well, you're already in 3D Game Lab. What you see in your quest here, I'm trying to click on it, is you're going to have a list of some congruency combinations. So click on each one of these. You're going to take a screenshot and I'll show you how that works. The first example, since you may have missed the first day, is that side, side, side. If we have 2 triangles and we know that the 3 sides of both triangles are congruent, do we know that the 2 triangles themselves truly are congruent, meaning all 6 parts are congruent based off these 3 parts, the 3 sides? So let me show you in a couple examples here how you're going to go about this activity. So the first one I'm going to do is this 3-side combination here. So let's construct a triangle over here somewhere that has these 3 sides in it, and we're going to check to see if they're congruent. Okay, so what we have to do is start with a side of the triangle that's congruent to one of these sides, and it's our choice of which one we want to start with. Maybe I'll start with this blue segment BC. So when it comes to segments, there's going to be 2 tools that we need to use. One is in the segment and the line toolbox. It's called the segment with given length tool, and we'll be using that first. But also in your circle toolbox, we have the compass tool that we'll use as well. Okay, when it comes to making angles, which I'll show you in the next example, we're going to use the angle with given size tool. Okay, but first things first, let's make a segment congruent to BC. So I'm going to go to my line toolbox. I'm going to grab my segment with given length tool. I'm just going to click somewhere on the screen, and it's going to put an endpoint down. And now it's asking how long do we want the segment to be. And I want it to be as long as this segment BC. So in my input bar, I'm going to type, make sure your letters are capital, BC. So this is going to be the length of BC, and I'm going to hit OK. And I'm going to make it blue just so that we keep it orderly here. Okay, so now the next thing that we need to do is either build the red segment or the orange segment, our choice. Maybe I'll do the red one next. So what I want to do is use the compass tool. So now I usually use the segment with given length tool for the first segment, and then after that we're going to use the compass tool, and hopefully through these examples you'll see why. So if I grab the compass tool, what I'm going to do is I want to make compasses make circles, that's why it's in the circle toolbox. So when I click on the segment that I want to copy with the compass tool, so I'm going to click on segment AB, and it makes a circle that, if you notice, if I center the circle on an endpoint, that segment's a radius, right? And that's really what compasses do. They let us set a radius and then we have a circle. So what I'm going to do is make the circle then centered at one of my endpoints, like say D. So I'm going to click on D, and now we set the circle. So every radius of the circle then is going to be the length of AB, right? So if I put a segment here and make it red, that segment is the length of AB, that red one. So now I need to make my third segment, this orange one, AC. So I'm going to do the same thing. I'm going to grab the compass tool. I'm going to click on AC. It just makes a circle. Oops. Makes a circle with that segment as a radius. So now I'm going to center my next circle over here at E. Okay. Now what we can see here is if I move my original red segment around, I can put it on that intersection, and I can also make my third segment on that intersection point, right? So there's our triangle that we just made, 3 sides. Our job now is to determine whether they're congruent or not. Now, one thing that I don't really like a lot about just having the segment is that this can move. Really the only point that we can make that satisfies the actual length here is when we use that intersection of our circles. Okay, so I'm actually going to delete that point, and I'm just going to stick a point on the intersection. So now this segment here is our orange segment, right? That's the radius of the circle. This segment here is our red segment. So there's our construction, and notice it forces one triangle here. We could also make it down here too, right? So maybe this is our red segment and this is our orange segment. But I hope you can see that those two triangles are really just reflections of each other. So this triangle here, whether if we chose this intersection, is going to be congruent to this triangle if we chose this one, because they're just reflections of each other. Okay? So it doesn't matter which ones we do. I'm just going to stick with this upper one for right now. So we just made the 3 segments congruent to these 3 segments. There's our 3 parts. Let's check now to see if these are truly congruent. So we know, based off our construction, this red segment, so I just went into the measurement toolbox and grabbed my distance or length tool. We're going to use that tool to measure segment length. So click on your segment and it'll tell you the length. So those are congruent. These are congruent. We made it that way through construction, right? Shouldn't be a surprise there. Now to check the additional 3 parts, let's measure our angles. So now I'm going to click on maybe check angle BAC, or angle A, angle ACB, and angle CBA. And I just want to check over here if the 3 angles are also congruent. Notice 51.55, 51.55. This one is 35.26, that one's 35.26, so then this angle must be the same as well. 93.19, 93.19. So we're showing in our screen, or in our picture right now, even though we constructed the second triangle based off the 3 parts, in this case the 3 segments, the 3 sides, the additional 3 parts, the angles in this case, fell out to be congruent. So therefore, all 6 parts of both triangles are congruent to each other. That means the triangles are congruent, and we can write a congruency statement then. So I'm going to grab my pen tool, and I'm just going to say triangle ABC is congruent to triangle, looks like F corresponds to A, B and D correspond, and then E is our last point. So this would be a screenshot in the quest that you would submit, because you're showing all 6 parts are congruent. Therefore, we can make our congruency statement, and we would submit this into our quest submission, right? So whether you want to do a Word document and compile a screenshot for each one of these, do that, or just save each screenshot and then individually put them into your submission. Either way you want to go about it. Okay, so let's do one more example. So in your quest, you don't have to do the side, side, side one. I did that in class. So you have 5 more combinations of our 3 parts here. So you have 5 of these to do on your own. I'm going to choose one of them, like, what which one did I pick? Let's pick angle, side. I'm going to pick that one. So I'm giving you an extra one here since you missed class and you're watching this video. I'll show you how we can do angles. So angle, side, while this is downloading, means that we're going to have a triangle. We're going to construct a second triangle by making sure that two angles in that triangle are congruent and a side. There's our three parts. And then once we make our triangle, we're going to see if the additional three, so therefore all 6 parts, are congruent, therefore stating the triangles are congruent. So when you open up one of these GeoGebra files, it has highlighted the information that we need to construct in our second triangle. Since this is an angle, side, the way that it's written, by the way, the side is not in between the two angles like you would see in this example where we have angle, side, angle. The difference between angle, side, angle, we have two angles that we need to make congruent and a side in between them. Whereas here we have two angles that we need to make that are congruent and a side not between them. Okay, so here, for example, here's our two angles and our side not between the two. Angle, side, angle would be like this angle here, the side in between this angle here as well. So our angle, side, angle. So make sure you understand that order thing. Okay, let's construct this one. Whenever you have a segment to construct, we're going to do that segment with given length tool. So I'm just going to create my segment. I'm going to make it the length of BC. I'm going to go ahead and make it red just like the picture so I can keep that in mind, that that's the same length as that. So now I need to make some angles. Well, this angle here, this green one, alpha, is part of that segment I just made. So I'm going to use that segment as part of my angle, and I'm going to make that alpha angle go off of, say, point D. So to make an angle with a given size, because we know the size of it, we want to make it this angle, I'm going to go to my measurement toolbox and grab the angle with given size tool. Okay, we click on 2 points with this, so I'm going to tell GeoGebra E is on one side of my angle, D is the vertex. So whenever you use this tool, second point you click on is going to be the vertex. So I'm going to get rid of that 45 degrees and I'm going to put in an alpha instead because that's the name of this angle. I'm calling it alpha because that's what it is. I'm going to open up either way, it doesn't matter which way. Counterclockwise, it's going to open up. So what happens is when you use that tool, all it does is it rotates this endpoint E around the vertex by whatever angle we said. Since alpha was 71.06, it rotated the point 7106. Okay, so to finish off our angle, angles, by the way, are just rays that share a common point, which is the vertex. So we don't have a side restriction here to meet, just that one red segment, we already have it. So what I want to do is finish my angle off with a ray. Okay, so I'm going to grab my ray tool, I'm going to click on the starting point and then the point that it goes through. Okay, so rays are nice because it tells us the direction of the angle, but we don't have to worry about segment length because we have no side restriction to meet. So I'm done with this point here. I've created my angle. I don't want to use this point because it's kind of confusing, so I'm just going to hide it. And now what I'm going to do is stick a point on the ray so that it can move around. So if I grab my move tool, I can slide that point around, right? And since we don't have a side restriction, we don't know how far this point needs to be, and that's okay. But now I'm going to make this point F that just popped up be the vertex of our next angle, this blue one up here. So now I'm going to grab my angle with given size tool. I'm going to click on this vertex, or that point, click on F, that's my vertex. And I'm going to make it the variable of this angle, which happens to be B, or beta, in the Greek alphabet. And I want to open counterclockwise, I believe. So there's my point that I know my angle has to go through. So I'm going to grab my ray tool again and finish off my ray. So now we almost have a triangle here. What we have to do to actually make a triangle, and I'm done with this point again since I made my ray with it, so I'm just going to hide it. And now as we slide this point around, we want to stop when that ray actually goes through our third point, and we can see that triangle that's made now. Okay, so now to check for congruency, we want to just use our measurement tools. You would click on the segments to get their length, or since these are rays, if you want to get the length or the distance between the points, you want to click on the points. So notice those are almost the same thing. They're off by 100th because maybe it's human error that we could get that to 4.17 really. So that segment really is congruent to that. Oh, I had it, but now it's gone. Okay, so we are going to call those equal, even though I can't get it there. But we could check this distance between those 2 points and check this distance or length in 4.41 and 4.4. Really, those are the same thing. These segments have to be the same length because we made it that way. And then we would just check this angle. So I'll grab the angle tool, and I'm just going to measure this angle, measure this angle, and see, hey, again, off a little bit. It's all due to this human error side of it, but if we can agree that they should be, I really want to get that. It'll probably take 20 more minutes in this video. Anyways, that's good enough. This is the only one where you're going to get that little bit of human error variable going on there. But we can see, I hope, that all 6 parts truly are going to be congruent to each other. So then we would just write our triangle congruency statement. We'd say then that triangle ABC is congruent to triangle. It looks like A and F, and then B goes to D and E. So we know that they're congruent, therefore we just practice our congruency statements. That triangle is congruent to that triangle. Okay? And then save that screenshot or put it in a Word document and continue through the quest until you get them all and submit that. Okay? Good luck to you guys.